5:05 now, and we will get started. So, welcome everyone to the third of our penetration testing workshops. For those who are joining here for the first time, I'm Utku. I'm the IT coordinator of BitSoc, and we are collaborating with Netsoc to bring you these workshops. Today, we will be focusing on privilege escalation on Linux systems. Just to make a reminder again, uh, my advice for you is to watch this presentation and watch the demonstration and then do the challenge yourself after the workshop is over. Because if you try to follow along as I'm doing things, you might miss some of the stuff and you might not understand why I'm doing certain things. So I heard some people had problems following along in the second lecture, second workshop. So I wanted to remind you this. So with that being said, let's get started. So privilege escalation. Privilege escalation is the process of an attacker gaining elevated access on a system. This meaning that on a Linux system, the most powerful user is the root user. But when you get an access to the system, you might not always be the root user. In most cases, you will be a low-level user, such as www.data or any other low-level user in the system. So when we're talking about privilege escalation, there are two types of privilege escalation. One is horizontal privilege escalation, which is an attacker gaining access to another user who has the same level of access. And the second and the most important one is the vertical privilege escalation, and that is an attacker gaining access to another user who has a greater access level. So when you're doing CTFs, when you're doing penetration tests, you will most likely be looking at vertical privilege escalation because the goal is to get root and the goal is to become the most powerful user on the system. So we will talk about that right now. So first of all, why we need privilege escalation? At the top, I have shown you a basic overview of Linux file system. So as you can see, we have many directories, and we have the root directory, which is the home directory of the root user. And as you can see on the bottom, we have some information regarding that root directory. So on the left, you will see 10 places. So the first place that says D, it specifies that it is a directory. The file is a directory. The tree section after that directory section are the permissions of the owner of the file. So as you can see, this file is owned by root, and in Linux, the permissions are read, write, and execute. So as you would expect, the owner of this file has all the permissions. And the next tree section indicates that the permissions of the group that the owner is in. So if you're in the same group with the owner, then the next three lines are indicating your permissions. And the last three lines indicate the permissions of everybody else. So everybody else. So when we look at this 10 section, we can see that the owner, the root user, has all permissions to the file and no one else. No one else has any permissions on that file. So only root user can access the root folder. So if you're another user other than root, you cannot access that file. And usually when we are playing CTFs, the root flag is under the root directory. So you will have to be root in order to get that directory. Also, if you're talking about penetration testing in general, if you want to have full access to the system, run any command and access any files, you'll have to be root. So that's why we escalate privileges. So I want to talk about some important files on the Linux system. So the first one is the etc password file. The etc password file stores user account information. As you can see, the permissions of this file, the root user has read and write permissions. The group of the root user has read-write permissions as well, but everybody else has only read privileges. So it is a plain text file, and anybody on the system can actually see the content of the file. And as we look into the file, we get some very valuable information. So the first section, it indicates the name of the user. The X indicates that there is a password that is stored on the system for that user, but it is encrypted. So the next two sections, 0 and 0, they are the user ID and group ID. So the root user has a user ID of 0, and root's group is also, the group ID is also 0. Then you will see the name of the user again, their home directory, and the bin bash indicates their shell. So as you can see, this information for other users on the system as well, and we will be looking at the etc password file when we're doing the demonstration as well. So the next file is the etc shadow file, which is a text file that contains encrypted user passwords. As you can see, the permissions, the root user has read and write permissions. The users in the group of root has read permissions, and nobody else has any other permission. The encryption algorithm to store the password can be MD5, blowfish, or secure hashing algorithm. As you can see, here is an example of the contents of the etc shadow file. As you can see, the first part indicates the username, and also following dollar, as you can see, it says $and 6, and that indicates that the hashing algorithm that is used is SHA 512 bits. So that's an example of the etc shadow file, which we will be looking at as well. And the next file that we will be interested in is the etc sudoers file. So if you have been attending the previous two workshops, you would have seen me typing and using the sudo command a lot. And I have been able to do that because I have been in the sudoers file. So the sudoers file contains users who has sudo privileges and which commands they can run with sudo. So as you can see, the sudoers file is only readable by root and the other users on the root group. And at the bottom, you can see an example of the etc sudoers file. So that brings us to how to escalate our privileges. So there are many different methods. We will be covering 5 methods today, which are all concerned with vertical privilege escalation. So the method 1 is to exploit SUID binaries. So SUID stands for set user ID, is a permission type that allows one user to execute that file with the permissions of another user. So to indicate an SUID file, we replace the X with an S. As you can see in the example, where you would usually see an X, there is an S on the section that indicates the permissions of the owner. So, and because the owner is root, when this file is run, it will execute as root. It will run as root. So you can find SUID binaries with the command that is given below, which we will be using. And they are really important to get root privileges, because if these files, if these programs, when run, uh, if they are spawning a shell, because they're running as root, we will be getting a root shell. So the second method would be exploiting the path variable. So path variable is the environment variable which contains the path of binaries that the system looks at when running a command. So in Linux, everything is a file. Every command that you run, every binary is a file. And those binaries are stored usually under the bin or sbin directories. So when you type a command on the terminal, before executing that command, your system goes into the path where that program, that binary is stored, and executes that command from that path. So path variable can be exploited by adding a malicious binary to the path. To see the path on a Linux system, use the command echo $path, which we will be looking at the demonstration as well. So three other methods. The third one is exploiting sudo write. So if you're a user with sudo privileges, you can run sudo binaries that can elevate you to root. So it all depends on what type of commands you can run as root. Method 4 is exploiting cron jobs. So cron jobs in Linux are scheduled programs that run at the defined time period. So in Windows, it is similar to task scheduler. If you have used task scheduler before, you basically schedule a task at some time, or you schedule a task to run at a period of time, and that program gets run automatically by the system. So by modifying existing cron jobs, you can get root access as well. And the last method that we will be covering today is exploiting misconfigured permissions. So some important files on the system, such as the etc password file and the shadow file, must be only modified by the administrator. So if another user has access to modify these files, then they can cause some serious damage. They can add another root user to gain root access, which we will be looking at. So last thing we are going to cover today is a tool called linenum. So linenum is a script that checks for local privilege escalation attack vectors, and it can be used to automate and shorten the process. So right now, we will be looking at how to find privilege escalation attack methods manually. And then at the end, we will run linenum to see how we can shorten the process and actually automate it. So with that being said, I know I've covered a lot of stuff, and I know that uh, I may have been really fast, but with the demonstration, I am hoping that things will be much more clear. So let's get on with the demonstration. So as always, I'm running Parrot OS as my attacking machine, and we have the Escalate Linux box as our target. We already have initial access to the system. I'm not going to cover on how to do that, because we have covered on how to get access extensively in our first two workshops. But the instructions on how to do it has been sent to you on the PDF, the CTF Solutions PDF. Yes, you can do this on Kali as well. Well, Kali and Parrot, they're both penetration testing focused operating systems. They come pre-installed with hacking tools, and they are very similar. Parrot is a lighter operating system, and it comes with more tools. And yes, you can okay, so you can do this on any Linux system, which I've covered this on the first workshop. The difference is that with Parrot and with Kali, the tools that we use, such as Nmap, Burp Suite, Metasploit, they all come pre-installed with the operating system. So when you install the operating system with Kali, with Parrot, and some other security-focused operating systems, you can run these tools uh, after you install the system. But if you're not using a security focused operating system such as like Fedora or Ubuntu or Linux Mint, you would have to manually install all the tools. So you would have to manually install Nmap, or you would have to install Metasploit, which is like, if you're an experienced Linux user, or you can like you're curious and you can go and uh, find the ways on how to do it. It's very easy, very simple. Um, but yeah, so if you don't want to deal with that, use Parrot or use Kali. If you want to look into it, do that manually, then yeah, you can do it as well. But back to the topic, yeah, much easy this way. Yeah, I agree. So back to the topic, we have got our initial access to the system, and as you can see, we are currently user 6. So the first thing that we want to do is to find the users on the system, and we can do that by looking at the etc. As you can see on the system, at the top we've got our root user right here, and at the bottom we have the users on the system that are created. So we have from user 1 to user 8, and they have their user IDs, their group IDs as well. So the first thing that we want to do is to look for the SUID files. So to find these SUID files, let me make this full screen. To find these SUID files, we are going to use the command find, and then we're gonna go perm qs dash type f2 greater than dev and null. Okay, I did a typo there. Find dash perm, it's gonna be dash u dash type f2 greater than dev null. So this is going to find the SUID files that we are looking for. So we'll just wait a couple of seconds for the command to return the results. So as you can see, we have two interesting files in here. So as you can see, in the home directories of user 5 and user 3, we've got two files that are named script and shell. So I'm gonna go to the home directory of user 3. If I list all the contents here, as you can see, we have an SUID file. So this file with the S permission is going to run as root, and as the name suggests, it spawns a shell. So because the program is running as root and because it's spawning a shell, it will spawn a root shell because it has been run by the root user. So we will now demonstrate this by running this program. Sorry, shell. And as you can see, we are the root user. So that's the first method. So like I said, look for the SUID files, and you cannot actually look into the contents of the file. I mean, you can, but they're not plain text. So, but as from the name suggests, it spawns a shell, and because it has been run by root, it. Now I'm going to exit and become user 6 again. Now we will look into the second SUID file, which was under the home directory of user 5. If we list the contents here, as you can see, we have the file script. So we are going to run this script here and see what happens. So we didn't get root. It looked pretty similar with the other file, with the shell file, as it had the S permission, but we didn't get root. So why that can be? So we ran the script, and as you can see, it gave us the same result as if we are running the ls command. So we can think here that, okay, the other program was executing a shell. So, and that way we had a root shell. So it's the same way, the script file, it's not spawning a shell, but we can see that it is using the ls command because it is returning us the contents of the directory. So in this script file, the ls command is being used. Now, a programmer, a developer, can implement this two ways. The secure way to do this is that if you're going to use a command such as ls, you specifically define the path of the place where that ls command, the binary, exists. But if you don't specify the path and just type the command as ls, then we can manipulate the path that this command is being run. So as user 6, let's go echo $path. And as you can see, we have these directories. So what this is telling us that, for example, when we are running the ls command, the system is looking under these directories to find the ls program. Now, as an attacker, what we can do is that we can add another path to another directory and make another ls command. So how we can do that is, first of all, I'm gonna go into the tmp directory, and as you can see, oh, okay, so in here I can create a new binary for the ls command, and then make the path here so that when the ls command is being run in the system, it will look at the ls command here and execute that ls command. So what I can do here is that I can go echo, and I want to see the contents of the etc shadow file. So I'm gonna go echo cat etc shadow, if I can write, named ls. Now if you look, we have a new binary created by our user, and if we see the contents of that file, we can see that it says cat etc shadow. So right now, what I'm going to do is that I'm going to give all permissions to this file. And now I'm going to add a new path. So how I can do that is by export path equals the directory that I want. I can see that the TMP directory is now in our path. So what that will do here is that if I type ls, as you can see, I cannot list the directory right now. Because when I type in ls, it looks at the TMP directory, it finds the binary that I created as ls, and it runs that program instead of the usual ls that we have. So what we can do here is that, and obviously because we are not the root user, we cannot see the etc shadow file. So what I can do here is that now if I go back to the home directory of user 5, the etc shadow file with all the users and their encrypted passwords. So just to make a summary back, the script file was normally listing the directory, but I changed the path of the ls command with the malicious ls command that I made. And now whenever the ls command is being run as user 6, it is looking to the path that I specified, and it is running the ls command that I specified, which I said cat etc shadow. And as you can see, we are seeing the etc shadow file. And why is that? Again, the script file is being run as root. It is running ls, it finds my binary, and because it is the root user, it allows us to see the etc shadow file. So what we can do after we have the etc shadow file is that this is the hash right here. So we can crack this hash. So I already have this this hash in here. So right now I'm going to use a tool called John the Ripper to crack this hash. So to do that, I'm gonna go John and I'm gonna specify the file name. And if I hit enter, for some reason it couldn't crack the hash right now, but it can be because it has already done it again. Oh, it said loaded one password hash. But if you crack this hash, the password is 12345. So there is another way that you can. So once you read the etc shadow file, you can get this hash and you can crack this, and you can get the root password. So it's when you crack it, the result is 12345. So if you go su root and 12345, we get access to the root user. Okay, so that's another way. So because right now I'm the only person in the chat, that, do you have any questions as of now? So I will give a 5-minute question break before I will move into the other methods. So if there are any questions, any concerns, it's time to write it right now. What is the permission of the script again? Okay. ls-la user5 script. Oh, sorry. ls-la-home-user5 script. So as you can see, it's read, write, and then there's the SUID bit. And yeah, you can see the permissions in here. The fact that it's owned by root is important as well. Yes, so as you can see here, it specifies that the file is owned by root, and the group of the file is also the group of root. So because it has S in here as the owner, it is going to be run as the owner. And because the owner is root, it is going to be run as root. So right now I'm going to exit from the root user. I'm going to switch back to user 6. And now I'm going to go back to the TMP directory. But because, as you saw, I have a file that has root privileges, I can use those privileges to execute my script, my ls script, to change the passwords of other users on the system. So I'm going to go echo and then echo again. I'm going to change the password of user1 to 12345 to make life easier for us. And the command is change password. And then I'm going to go here and I'm going to put that on ls. So I'm going to do the same thing. Oh, okay, I got another question. And the execution permission has be set as well. Otherwise, an unprivileged user cannot execute. Yes, that is correct. So if we go back, as you can see, other users have the permission to execute the file. That's what that X indicates. So if there wasn't an X, then yes, user 6 wouldn't be allowed to execute the script. Yes, that is true. So I'm going to change the password for 2 other users as well that we are going to use. we wouldn't waste time, but for some reason, I don't know, I just couldn't see the file. Commands to change the passwords for user 1, user 4, and user 7. So if we go back to cd home user 5 and run the script again, right now the passwords of user 1, user 4, and user 7 has been changed. So I'm going to go and switch user to user 1. And right now you will see that there is a program called sudo as admin successful. So that what that means is that this user has sudo privileges. So to see these sudo privileges, we can go sudo -l, which stands for list. So we are going to enter the password for that. And as you can see, user 1 may run the following commands all. So we can run all commands as sudo. So what that means is that we can also run sudo su. So if we go sudo, we can get root. Really simple. So another scenario, if you sudo privileges, you can look, you can type with the command sudo l, and you can see that because we can run all commands, we can run sudo su and we can become root. So that's another scenario. Now I'm going to exit and talk about another scenario. I'm going to switch user to user 4, enter the password 12345. Okay, now we're going to talk about cron jobs, cron tab as so the scheduled tasks on a Linux system, they are stored in the etc cron tab file. So you can go cat etc cron tab. If I can type, you can see the scheduled tasks here. So at the top, we have a very interesting file here. So this file under home user for desktop autoscript.sh is a file that gets run once in 5 minutes, and it runs as root, as you can see. So if we look at the permissions of this file, I'm just gonna copy and paste it right here. As you can see, it is owned by us, user 4. So, and we have all the permissions. So right now what we can do is that we can modify this script to something that we want, and then when it runs as root, like for example, I'm going to modify this file to give me a reverse shell, and when it is run as root, it is going to give us a root shell. So I'm gonna go to the directory here, and when I let's see, here is the file. Now I'm going to change the contents of that file, and I'm going to change it with a reverse shell. So I already have a reverse shell written in bash. So I'm just going to copy this, and now to write into the file, again, I'm gonna go echo, I'm gonna go paste it right here, and then I'm gonna go greater than, and then I'm gonna specify the file, which is autoscript.sh. Now if I look into the contents of that script, as you can see, it has my reverse shell command. So I'm going to do two things here. What this command says here is that make a reverse TCP connection to this IP address, which is my attacking machine, on port 44444. So I'm going to open another terminal, and I'm going to use netcat, and I'm going to listen on this. If you wait 5 minutes, the system will run this program as root, and you will get root access. But I'm not going to wait 5 minutes, so I'm just going to show you what happens when you run it as root. So I'm going to switch user to root. Okay, so when I run the autoscript.sh as root, as you can see in here, because we were listening at that port, we have a root connection. So if you wait 5 minutes, can cron tab be used as maintaining access? Well, yes, you can have your program and you can have your program run at a period of time. Yes, you can do that. But the thing is that, usually the system administrators, they will be looking at the cron tab. So it would be a way to get caught. So not like it can be used, but not the best idea. So that's what happens when that program gets run as root, and we get a root shell. Now, the last thing that the last method that we are going to cover. First of all, let's close the connection here, and we don't need this anymore. And now I'm going to go and switch user to user 7. Okay, why did I switch you to user 7? I am going to show you the etc password file again. The user 7 user is very important because, as you can see, it has a user ID of 1006 but a group ID of 0. And as you recall, root has 0. As you can see, the root user ID and group ID is 0. That means that user 7 here is in the same group as the root user. Now, if you look at the permissions of the etc not shadow, the password file, as you can see, the group of the owner can actually write to this file. And because we are user 7 and we are in the same group as root, we can write to this file. So we can add another user. So to do that, I'm going to go again echo, and then I'm going to specify my user as test. That will be our username. And so rather than putting it an X here, we can actually put the password, the hashed password that we want to use. So although it didn't work last time, I'm going to copy the SHA hash for password 12345, and I'm going to paste it right here. So rather than having the X in here, we are going to have the hashed password. And also, because I want root privileges, I'm going to just copy this. I'm going to paste it right here, and then I'm going to write to this file, the password file. Oh, sorry. Okay, so if we go and see the contents of etc dash password, right now we can see that we have created our user with the password. So I'm just going to try and switch user to test with the password 12345. And as you can see, we are root again. So as you can see, the etc password file is very important. The etc shadow file is very important. The etc shadow file, if a user can access it, it can get the hashed passwords and then they can crack it. If they have write permissions to the etc password file, the password file, or how you call it, they can actually add a user with root privileges. And because, as you can see, we have the user ID of 0, the group ID of 0, and the home folder of root, and the like basically all the attributes of the root user, we can get root user. So besides that, those were the methods that I wanted to cover today, 5 of them. So let's see. The last thing that I wanted to cover is how we can shorten this process and how we can actually make automation. So as you can see, I've already transferred the linenum.sh to the system, and now I'm going to run it, and we will see what results we get. So this is going to take some time. So while this is running, I will be happy to answer questions. So as you can see from some of the results, it says we can read write to sensitive files. So it gives us the etc password file, and it is writable by the root group. We also it gives us the etc shadow file. So it looks for SUID files, and it has given us the SUID file user5 script. It is going to give us the shell file as well. Oh, it's right here. As you can see, the SUI under SUID files. So rather than typing in the commands and looking for the SUID files or files with misconfigured permissions, you can run this program linenum.sh and it can do it for you. So it will look at cron tabs as well, cron jobs as well. Let's see if it had done it or not. There's the SUID files. So it gives us a lot of information. Web server used version, MySQL used version, sudo version. So as you can see, there are a lot of information that you can get. The systems that are running. Shows you the permissions under important directories. It gives you the processes that are being run, the services, some network information is being given here. And as you can see, it gives, there is the cron tab contents. It gives you the scheduled tasks. And as you can see, you can pretty much automate and shorten the time that we had done uh, with the script. So that was the last thing that I wanted to show. And with that being said, the demonstration is over, and now I'm going to answer questions. So and this is available on all security versions of Linux. Are you talking about Linenum script, Hassan? Yes, no. So this is an external tool that has been written by, let's see who wrote this. So, so you can get the script from GitHub. Basically, you'll need to download it, and you can just run it on any Linux system, as far as I know. So yeah, that doesn't come with the security OSs pre-installed. You'll have to go and get the code from GitHub and run it. Any other questions? And also, I would like to get some feedback as well. This was the third workshop. Oh, there's the GitHub link. Awesome. Thank you, Drumil. So we have one more left, which is again in 2 weeks on April 4th, I believe, on Monday. So if you have any questions, any suggestions, I will be here for 3 more minutes. But if you don't have any questions, you can go. Yeah, thank you guys for joining. It's been wonderful. Yeah, so I guess there are no more questions. So again, thanks everyone for joining. And yeah, I will see you all in 2 weeks, hopefully, for our last workshop.